Proximal part, the wider part of ureter that is toward the hilum, is the renal pelvis. Rest of the ureter, of course, is more or less linear structure, and it enters the urinary bladder. We have a couple of models of urinary bladder here and there somewhere in the lab, but let me try to explain a little bit of what you will see in the model. The way I'm drawing it, I'm not saying it's male urinary bladder or female because I'm not including urethra. From outside you will see it like a bladder. Let's cut it open and see like this. This would be the urethra, the beginning part of urethra, this structure. Up here you have kidneys and the ureters coming. And we have models showing that, except the models are not that large that all of you can see. So the ureters come in. On purpose, I'm showing that the lower end of the ureter is embedded in the wall of the urinary bladder. In other words, I'm not saying that this is the urinary bladder and ureter comes in here and drops the urine. Not at all. The bottom part of ureter is embedded in the wall of urinary bladder so that the urine does not start backing into the ureter unless urinary bladder is excessively full. That's when you feel the pressure all the way into the ureters. Otherwise the urine stays here. And that happens because this part of the ureter, the distal end of the ureter, is embedded in the wall. Something to keep in mind. So as ureter comes into the urinary bladder, there is an opening by which ureter comes in. This is the opening of the ureter in the urinary bladder, therefore ureteral orifice. Everyone knows orifice is opening. It's the opening of the ureter, therefore ureteral orifice. How many ureteral orifices would be in a urinary bladder? Two. So this is also another one. And then there is an orifice here between the urethra and the urinary bladder, so that when urination happens, the urine passes through the opening and enters the urethra. What would you call this orifice? It's not ureteral, is it? Would urethral be better then? It's the orifice of the urethra. So, urethral orifice. You have heard me say over and over that spellings are so important. The difference is only an H here. Urethral orifice, ureteral. Now what we see is, there is a part of urinary bladder that is triangular, and it looks like a little triangular space which is surrounded by three openings. This triangular part is called urinary trigon. Which is two openings here, one there, the space, the part of the wall surrounded by these openings, urinary trigon. And then this urethral orifice is guarded by a sphincter here, which is internal urethral sphincter. Because you don't leave openings unguarded, would you? No. You need some kind of guard here to keep the urine here. Obviously, this internal urethral sphincter is involuntary and opens up under the micturition reflex or urinary reflex, which is processed by the spinal cord. So we have a sphincter here. And then there is another sphincter that we learn to control by the training, which would be external urethral sphincter, very much like at the end of rectum we have two sphincters, internal sphincter and external. And external we learn by training. So same thing. This is internal, which is here between urethra and urinary bladder. External urethral sphincter would be located at different lengths from here, depending upon whether it is the male anatomy you are looking at or female. Obviously, in female, urethra is very short, and the two sphincters, internal and external, would be closer to each other. In case of males, the urethra runs through the length of the penis, therefore, the two sphincters, internal and external, would be farther removed from each other. But in general term, that's the sphincter and their locations and the openings and their location. This wall here, as we know, is very muscular wall. And these muscles, needless to say, involuntary muscle process the micturition process, which is the same as urination. When these muscles contract, the voiding happens. Of course, the wall is very muscular, but located in this wall is the muscle called detrusor muscle. And those who have taken module, I think 3 exams, have talked about this in their exam, detrusor muscle. And there are medicine that they advertise called Detrol. That means the medicine that regulates this detrusor muscle so that you do not have accidents and leakage and so on. That detrusor muscle is in the wall. Also, this organ has stratified epithelium here. And I said stratified, not making a mistake. Many layers of cells. What kind of stratified epithelium is this?
Within the bladder?
It's in the bladder, urinary bladder, not in the gallbladder, urinary bladder. Yeah. What kind of epithelium is that? What kind do you know in terms of epithelia? And I already said it's some kind of stratified epithelium. Let me check the topic of epithelium, lab exercise 8. Urothelium, because it is the epithelium of the urinary system or epithelium of the urinary bladder. Urothelium is also called transitional epithelium. It is stratified, it is many layers. Why is it called transitional? What does the word transitional mean to us? Word urothelium is clear to us, right? Epithelium of the urinary bladder or urinary organ is urothelium. So we know why it will be called urothelium. Why is it called transitional? Because the shape of the cell undergoes transition from time to time, depending upon amount of fluid in the urinary bladder. At one time, the cells may look long, that is columnar, when the urinary bladder is not too full. And then as it begins to fill, the cells flatten out. They might look more cuboidal, more squamous. So all other epithelia that you have studied so far, the cell shape is either cuboidal or squamous or columnar and remains that way. Except here, where shape of the cell, it is stratified. It has many layers, so we know it is an example of stratified. But this is unusual stratified, where you cannot say it is stratified squamous or stratified columnar or stratified cuboidal, because at any given time the shape would be different. Shape of the cells undergoes transition from time to time, therefore transitional epithelium. And that transition is based on how much filling is taking place, how much it has filled. And because of that wonderful kind of epithelium here, where shape changes, the wall does not burst, even if too much fluid is in there sometimes. The wall can stretch, the cells stretch out, they become more flat, then they would be column-like, yet the epithelium remains intact. So transitional epithelium in the urinary bladder. So structure of the wall is in front of you now. What else do you want to know about this organ? You would want to know, given a model, you would want to know whether it is the male urinary bladder or female urinary bladder. Also, given the model, you would want to know whether it is male urethra or female urethra. In the models, you'll be able to tell male, female urinary bladder, because in case of males, on the outside surface of urinary bladder, if the model is correctly made, you would have two glands, one on each side, called seminal vesicles. Obviously, females would not have it. If the model is meant to show that difference between male female, then the model would have seminal vesicles on the outside surface of the urinary bladder. If it's mid-sagittally section urinary bladder, you'll have only one side and one seminal vesicle. Obviously, as I said, in females you would not see that. Also, the length of the urethra, like I said, is shorter in females, and urethral orifice, that is external urethral, this is internal urethral orifice. Internal urethral orifice with the sphincter there. In case of females, the length of the urethra is much shorter, and external urethral orifice is separate and apart from reproductive opening. In case of males, one opening is being shared between urinary system and reproductive system in males. Same way as one passage, the urethra is being shared for reproductive and urinary purposes. So remember this important fact. In case of males, when the model is given to you, if you are asked to identify urethra and classify the urethra, make sure you classify it into male urinary system and male reproductive system. That one urethra has double classification. Out of all of the urinary organs, no other organ has double classification except male urethra. In female, there is no crossing over. But in case of males, you would identify urethra as part of two systems, or you get no credit. So you would use that fact. Also, in many of our models, you would see that when you see the male urethra, you would be asked to identify three segments of male urethra. One segment, the beginning part, this part here. Let's say this is the male urinary bladder. The beginning part of urethra runs through the middle of this nut-like gland, which is the prostate gland. So the beginning part of urethra in males would be called prostatic urethra, because it's running through the prostate gland. The next short segment, of course it takes a 2 units of shape changes here. The next short segment, very short segment, runs through the urinogenital membrane, that is the base of the pelvic cavity. This part would be membranous urethra. And then rest of the urethra runs through the length of the penis, therefore penile urethra. We'll look at this again under male reproductive system, but right now we are trying to wrap up urinary system. So in case of males, the urethra would have 3 segments for you to identify: prostatic urethra, membranous urethra, and penile urethra. In females, you wouldn't do that. Any questions at this time? Okay, this is a good segue to go ahead and check the urethra model and then sign you up.